What do you do now? So hey guys, the only thing that we haven't done yet is write the equation given in ordered pair. Now, I usually have saved that for last because we've gone through all the shifting, we've gone through all the parts. We still know that A is always the distance from the center to the vertex. We know B is always the center to the co-vertex, and C is always the center to the focus. We know how to solve for A and B if we have A and C. We know that A squared plus B squared is C squared for hyperbola. A squared minus B squared is for the ellipse. We know to find the p-value of a focus is 4p. We set it equal to the stuff out in front. So we know how to do all of that. But what happens if I just have this information? Well, I have to write the equation of a parabola whose vertex is at -2 and 1 and whose focus is at -3 and 1. Well, what do you think you should do first? Graph it. Exactly. You graph it. By graphing these things, it automatically tells you what direction everything goes. It will always tell you what direction things are going. So if I have a vertex at -2 and 1, and a focus at -3 and 1, what direction is this opening? It's opening to the left. Because your parabola, or your vertex, always looks at the focus. It's a parabola, so you know it's a single curve. It has to do that. So, which equation is it? The x squared or the y squared? It's the y squared, right? Okay, yeah. So I'm saying, like, y minus k, 1a squared is 4p x minus h. All right. Well, what's your h and k? H is -2, and your k is 1. So we know already y minus 1 quantity squared x plus 2. Yeah. Let's figure out what p is. P is the distance between what two points? Vertex and focus. In this case, that distance is? It's 1, but it's opening to the left, which makes it a -1. So your p-value here is -1, so your answer is? Sorry, yes, it's -4. Sorry about that. There's your equation. What direction is it opening? Is it a positive or a negative direction? How far apart is the focus and the vertex? There's your p-value. It's the idea of knowing. You can have the formulas and the equations all day long. You still have to know what everything means. And that's the idea. As long as you know what they mean, you're fine. Okay? You have to know what they mean. Okay? I don't know. I'm scared. If writing the equation of the circle takes you longer than to write down the problem, you're doing it wrong. Circle equation, and that's the other thing. They have to tell you what it is. I mean, you don't necessarily need to know. If you know you have a vertex somewhere and a focus somewhere else, if you have ellipses versus hyperbolas, if you graph them, you're going to be able to tell right away if they're opening towards each other or they're opening away from each other just by ordered pairs. So you don't have to be told. But with a circle, you see the word radius. It means it's a circle. So, x minus h, 20 squared, y minus k, is r squared. Well, what's your h and k? 4, -1, yeah. Super fast. I have such a habit of writing it out like that, of saying, oh, it's 7 squared, which is 49. If you write just equals 49, fine. Doesn't matter. For some reason, I always just did it that way. I don't know why. Just did it. Yeah, you can just write it as equals 49. I'm going to go out on the limb and assume I don't need to do another circle example. They're always going to be your favorite in a roundabout kind of way. I'll also have stuff where we can write equations. All right, let's try something different now. Let's look at the ellipse. Write the equation of an ellipse with foci at 3, 5, 3, negative 1, and vertices at 3, 6, 3, negative 2. Again, what do you think you're going to do first? Yeah. Conic sections in this stuff is so very visual. And it's kind of the nice thing that it's one of the few things in Algebra 2 that you can actually draw all of this. Same thing goes for when we get to trigonometry. When we get to trigonometry, we talk about unit circle stuff. Everything is visual. Everything bounces off into a certain quadrant. Everything has a specific value. And if you can replicate what things look like, everything else falls into place. So we start here. I have foci, at 3, 5, and 3, negative 1. Right away, what direction does this tell me this has to open? It's got to open up and down. Okay? It has to open up and down because they're above one another. So in my mind then, I know that I'm going to do an x minus h quantity squared over a b squared. I know it's going to have to look like that. Because if it's opening up and down, that means according to our diagrams, the a squared is the larger of the two, and it's underneath the y. You okay with that? All right. So there's my foci. Vertices are at 3, 6. And what was it? 3, 6, and 3, negative 2. So here's my. Ooh. It's still really bad. What happens at the midpoint of vertices? It's the center. Okay. So what's 6 plus negative 2? What's half of 4? 2. So my center is at, my HK is at 3, 2. There's my H. There's my K. The distance from the center to the vertex is your A value, isn't it? How far apart is 2 and 6? 4. Oh, I took my vertices. My vertices were at 3, 6, and 3, negative 2. I'm just getting the midpoint. What's happening? And I don't have to worry about the 3 because they're all vertical one another. So I just took 6 and negative 2. I got 4. What's half of that? 2. Okay. So then it gives me my A value is 4, which makes A squared what? 16. I don't have anything here about B, but I do have something here about C. How far is it from center to focus? 3. Now we have to think about A squareds, B squareds, C squareds with an ellipse. Am I adding them or am I subtracting them to get C squared? I'm subtracting them. So 16 minus what is 9? 7. So here's your answer. X minus 3 quantity squared over 7. Oops. Y minus 2 quantity squared over 16. No, because when you're writing out the equation, this is a great question, guys. Rather than just asking, do you have to label everything where all your vertices and all that other fun stuff is? No. And quite honestly, the only thing you'd have to figure out is where the covertex is. You'd have to add that plus minus root 7. Whatever, we can do it. But whenever I ask you to just write out the equation, this is all you have to give me. That's what we look like. Okay, it's just a matter of counting quite literally how far apart these are. That's why I kept pounding into you guys. Your A value is always your center to your vertex. Your B value is your center to your co-vertex. Your C is always your center to your foci. So that way, when you saw things like this, you know all you have to do is count and manipulate. All right. Sir. We knew that right away since they were vertical of one another. If I'm looking at my calculator, if I'm looking at my little cheat sheet, when I have an ellipse that's going to be vertical, the A squared value is going to be underneath the Y, because that's why it's stretched that way. That's why I wrote that down first. Okay. Yes, ma'am. In a sequence of events, all you have to do is write the equation. Yes, sir.
Why'd you put the 7?
Remember when you have the ellipse, and that was the last little part. A squared minus B squared is C squared. Remember when we had the relationship between the A's and B's for the ellipse, was you should subtract them. The relationship between the A's and B's with the hyperbola, you would add them.
Okay.
And the reason we remember that is because it's always going to be the opposite of that. Yeah. But you know that they're always going to share either an x coordinate or a y coordinate, so you just take the average of the other two numbers. It works the same. But if you want to do it that way, perfectly fine. And that's the one reason why this section starts with distance formula midpoint. I always just count. Yeah. Vertex to 7. Always. We just count. All right, let's try a hyperbola. Let me blow that up so you can see it better. Hyperbola with foci. Sorry. Hyperbola with foci. And vertices. Remember, when we're dealing with ellipses or hyperbolas, you have to have 4 sets of ordered pairs to make it work. Whereas if you have a parabola, you kind of have 1 ordered pair and a directrix, 1 ordered pair and a focus, or you could have a focus and a directrix. Okay. Whereas these two, if you just had 4 ordered pairs and you knew that one's a vertex and one's a foci, if you didn't know it was a hyperbola and you graphed it, you're going to be able to remember that vertices open to foci, vertices open, or vertices open to foci that could be enclosed. All right, so it's the idea that you can do this without having to know what they are, and I'll give you some examples of that tomorrow. So we start by plotting 5, 2, 5, -6. So right away, which direction should this be going? It's going to be going left and right. Now, are you holding your paper sideways? Don't do that. It's I may or may not have screwed that up. Hi. Hey Nina, whatever you do with your paper is fine. It's fine, no worries. Apparently, standing next to a smartboard all day kind of puts the plutonium in the brain. Anyway, so what way is this going again? Yeah, it's up and down. Woo! So what value comes first if it's opening up and down? again, when you have things that open up and down where you have y values going first, that's usually where you guys will make a mistake. You will accidentally rewrite h's and k's as k's and h's. Be careful. So there's your foci, your vertices at 5, 0, 5, -4. Hey, look, I grabbed this one, right? Thanks. It's like I did, which puts my which makes my h and k at what, 5, -2. There's my h and k. A value is the distance from your center to your vertex. Let's see if I can count this correctly. 1, 2. Our B value is for covertex. We don't have that, but we have a C value. 1, 2, 3, 4. So our A squared. I know I should, right? Someone get a calculator. And going back to the idea of how do you figure out work with A squareds and B squareds when you have your hyperbola. Remember, it's always going to be the opposite sign of the conic. Our conic has a negative, which means it's going to be A squared plus B squared. So 4 plus what is 16? Okay. So your answer works out to be y plus 2 quantity squared over 4 minus x minus 5 quantity squared over 12. A squared plus B squared is C squared. A squared plus B squared is C squared. A squared plus B squared is C squared. Look, guys, look. Because it's so hard to visualize what it does, how it came out. The conic sections, if you take a cone and you slice it, that's where it comes from. Yeah, that's where all the conics come from. What I want you guys to look at here, it's that 10-6 as well. I want you guys to do 13 through 20. So it's on the 628 side. So you'll have to go back a day or so for the PDF file, which we'll figure out. What I want you to do is on 620. What's that? Yeah, the PDF link isn't there. You just have to go back to like last Thursday, wherever it was. Do those. It's just right now, there's 2 of each style. Tomorrow, what we'll do is I'm gonna show you guys how you can do that, especially with ellipses and hyperbolas, without knowing that it's an ellipse or a hyperbola. Like I just said, if you have the 4 ordered pairs and you know if it's a vertex or a foci, you can graph it. You can do it. Okay, we'll go from there. Oh, excuse me. Oh man, what's killing me? Good times. Yeah. Yeah, because if you take a double cone, you slice it with the hyperbola. If you take a cone and you slice it through, you get a circle. You slice it at an angle, you get the ellipse. Yeah, like are hyperbolas. Gotta leave you something to learn and freak out. We're actually, you know what? We're gonna use something very similar to that in about 2.5 months or so. Because that idea of that slant asymptote, you get that with polynomials. See you guys.